Hello students, let us start a numerical on steady state pattern. This is going to be a very different kind of numerical, so better pay attention on it. So it's in a biprism experiment. The distance between two current source is 0.5 mm and that the distance between the slits and the eyepiece is 1.2 meter. The slit is illuminated by the red light of wavelength 6550 angstrom unit. Now the question is, if the red light is replaced by the green light, which is having wavelength 5240 angstrom unit, you just need to find that nth red bright band coincides with the n plus 1th green bright band. Then what is the question? The question is calculate the distance of this band from CBB, that is central bright band. You would first of all write down the given data, and the first one would be nothing but small d, that is distance between two coherent sources is 0.5 mm, and mm could be written in terms of meter. This can be further simplified as nothing but 5 into 10 raised to minus 4 meter. So then the next data, it goes for distance between source and the screen, that is slits and the eyepiece. Capital D is 1.2 meter, and I can just go on by writing down the wavelengths of red light as well as green light. So lambda r is 6550 angstrom unit. You can convert it in terms of meters. So it would be 6550 into 10 raised to minus 10 meter. Then I can also say that wavelength of green light is 5240 angstrom unit. Then this would be 5240 into 10 raised to minus 10 meter. So this was given. Now the condition, what happens when red light is replaced by green light is their nth bright band and n plus 1th green bright band is going to coincide. So I can say xn for r is nothing but going to be equal to xn plus 1 for g. Because students, what is xn? Xn is the distance of the nth band from the central bright band. And what is xn plus 1? It is the distance of the n plus 1th green bright band from central bright band. Now if both are coinciding, then the condition of coincidence is nothing but the distance should be same. That is xn of r should be equal to xn plus 1 of g. So this is going to be the very important condition, students. Just keep this thing in mind. So what is calculation required? It's going to be simple. We just are going to calculate what is the distance between the both bands, right? Either the green band or either the red band. So I'd be like xn of r should be found out, or xn plus 1 for green should be found out. So this is clear. We would be taking care from the formula xn equals to n lambda d by d. So just try using this formula for particular given data. How it goes? Xn for r is nothing but xn plus 1 of g. So it would be like n lambda r d by d is nothing but equals to n plus 1 lambda g d by d. As we know, the experimental setup is kept intact. It's not changed. So this capital D and small d would be same. So they would get cancelled. What would be left is 6550n is nothing but equals to 5240n plus 5240. Now where these numbers came from is nothing but from lambda. We have just substituted value of lambda and we are getting it in terms of n here. So let us bring both the n terms on the LHS side by keeping the number 5240 on the RHS, and n would be equal to 5240 the whole upon 1310, and n would be nothing but 4. So I would say let us calculate xn of r by substituting value of n there, because we already knew what is lambda and d by dr. So it is going to be like xn of r is equal to 4 times of lambda into d upon d. I have substituted each and every value here, and the calculation is a bit simple in this case. So just by multiplying that, you're going to get xn of r is nothing but equals to 6.288 into 10 raised to minus 3 meter. Now you can also write it like 6.288 mm. So students, this was a very special numerical where you had been told what was condition for coincidence, and this is a format you need to use to get the distance from central bright band.